Hello friends, today we are going to see differential calculus function. This is part 4. In this we are going to see logarithm. We will discuss logarithm from the basic, from the 0 level to the higher level. Here I will discuss the only theory part and its properties, and after completing whole the theory of this whole function, then I will solve example. So by example you will have a better understanding of this topic, of this theory. If you have not watched my earlier videos, then you can find the link in the description. In my last session I discussed inequalities, number systems and modulus function and other things in a short way, so that you can grasp the knowledge easily in a short way, so you don't have to read whole the book for that topic. Now today let's see logarithm. So what is logarithm? When a logarithm is defined when a greater than 0 and b greater than 0 not equal to 1. This is read as log a to the base b. When log a to the base b is equal to c, we can write a is equal to b raised to c. How logarithm came into existence? So if we say 2 raised to 3 is equal to 8, so if 2 is equal to b, 3 is equal to c and a is equal to 8. So if we are given b and c, we can find easily 8 by exponential, means by power form. So if we are given a and b, then how to find c? When then concept came, then logarithm came into existence. So if we are given 2 raised to c is equal to 8, then how to find 8 is the answer. So how to find c? So logarithm came into existence. By logarithm you can find c. If we apply log to the base 2 to both the side, we will get c is equal to 3. So this is a basic thing you have to remember while solving an example. While solving any example, first you need to check that a is greater than 0. Second thing, you need to check that b is greater than 0 and not equal to 1. Then only you will be able, then only you have to solve the further thing. If it is given log a to the base b greater than 0, then if b is greater than 1, we can write a is greater than b raised to c. We can write directly if b is greater than 1. But if b is less than 1, then sign of inequality will change. Then we have to write a is less than b raised to c. How this came? Because if b is less than 1, so we have seen b is greater than 0. So if b belongs to 0 to 1, so in this scenario you will have all the number that will be in rational form. For example, if it is 0.5, 1 by 2 and all this, so when we will solve that, so inequality sign will change. This we can see by example. I will discuss further, but at this time you have to remember this point, that if b is greater than 1, we can write a is greater than b raised to c, and if b is less than 1, we can write a is less than b raised to c. Now let's see few properties. If it is, this I have already discussed, first one, if it is a log of a to the base b is equal to c, we can directly write a is equal to b raised to c. So now this first property discussed. Second, if it is log a to the base b, then we can write log a to the base p upon log b to the base p. We can add base and we can separate the a and b both. But here things should be taken care, that is p is greater than 1, greater than 0 and p is not equal to 1. This basic rule you have to keep in mind whenever solving any example. These two rules for a, for A and for B. Now third property is log A to the base B plus log B to the base B is equal to log of B A cross B. When it is addition, so we can combine that. So we can write log of AB to the base B. Similarly, in subtraction, it will get divided. And now if it is log A to the base B whole raised to m, means A raised to m it is there, so power will come ahead. Now next is this here, these two are important. Say log A to the base B raised to n. If the base has a power n, so we can take that ahead, but it will be 1 upon n, and then rest will be log A to the base B. This last one, A raised to log of C B. Base is C and with respect to B. So we can change the A and B because it is exponential. We will see this further by an example. So you have to remember these few properties. These are important properties because when you solve example, these properties will make your work easier. So from that point of view, these are important. Now, as we have discussed this property, now whenever it is log of x square, so what students are doing mistake, they are writing log of x square is equal to, this is a learn property ahead, so 2 will come ahead and we will write log of x. But whenever it is log of x square, take care, modulus sign will come, because as we have seen earlier, root of x square is equal to mod x, not x. So this thing we have to keep in mind, because we know that minus 1 square is also equal to 1, 1 square is also equal to 1. So this is a very important thing. Always keep in mind that first thing, it is that root of x square is equal to mod x, and this property is the same as that. So you should keep in mind, this is very important. And now see few cases. If log of a of x1 is greater than log of a of x2, if this is the case, then we have to check the a. If a is greater than 1, then x1 is greater than x2, and obviously we have seen that this x1 is greater than 0, so this is first case, so we can write x1 is greater than x2 greater than 0. What is the case 2? If a lies between 0 to 1, as I have said earlier, inequality sign will change. So here sign is changing, so x2 is greater than x1 and x1 is greater than 0. So we can write here x2 is greater than x1. Now see another thing. If log of x1 to the base a is equal to log of x2 to the base a, so we can write x1 is equal to x2. Now if in exponentialities a raised to x1 is greater than a raised to x2, then similar case will apply. If a is greater than 1, then we can write x1 is greater than x2, and if it is a lies between 0 to 1, we can write x1 is less than x2. Here inequality sign will change. Now let's see graph. Here I have drawn the graph with pencil, this a smaller graph. So if a is greater than 0, then graph of log s is like this. If it is 0 to 1, graph is like this, is decreasing. Here it is increasing. Similarly in exponential, a raised to x is like this, and it is 0 to 1. Let's see in different page. So if a is greater than 1, for we are seeing this for log x. If a is greater than 1, so let's change the color. So graph will be like this. If a belongs to 0 to 1, so graph will be decreasing. Graph will be like this. If now let's see for e raised to x. If a is greater than 0, if let's say a raised to x, a is greater than 0, so its graph will be increasing, a raised to x. But if it is a belongs to 0 to 1, then the graph will be like this. So this is for, sorry, it will be, this is a raised to x, it will be decreasing, same will be like this. Here it will intersect at 1, here it will intersect at 1. So this will be graph. Graphs are very useful when solving an example because it makes our work easier. Thank you for watching. I hope you will like this video. If you really like, then please do like and subscribe to my channel. Also press the notification bell for latest video. You can also share with your friends if you find this useful. Thank you very much.